Well, obviously these rare earth magnets, and rare earth magnets are relatively expensive.
Yeah.
So the less magnets you can use within a system, straight away you get a price saving. So the cost of the system is heavily reduced as the length increases. Okay,
Excellent.
because the only magnets used are here and never here. Okay, so that's one benefit.
Hey, it's Eamon at EDS. I'm at the Motion Control Products stand with Tony, and there's a very interesting motor here. So, Tony, can you explain a bit about what makes this is a linear motor
Yeah, this is a linear
special?
motor. Yeah, this is a linear motor, but it has no magnets on the track.
Okay.
So all the magnets within the system would be in the forcer only. So this is the track. It becomes as a segment, if you like, and you build these up into the length you require. It could be a virtually infinite length you could work to. Okay, as long as you've got the power and the encoder, there'll be an encoder mounted alongside here to note the position and the velocity of travel. As long as you've got that range, then you can go as far as you want. So the track is basically consists of a laminated metal material.
Okay.
And as you can see, it's got these teeth on it, and the forcer has the coils and the magnets in, which allow you to move along by. This particular unit has 3 coils and 3 magnets. By switching the magnets on in the correct sequence, you can move along the track and position very, very precisely.
Cool. So you mentioned it to me before, but for our audience, what's the key benefit of having the magnets in here itself rather than on the track?
Well, obviously these rare earth magnets, and rare earth magnets are relatively expensive.
Yeah.
So the less magnets you can use within a system, straight away you get a price saving. So the cost of the system is heavily reduced as the length increases. Okay,
Excellent.
because the only magnets used are here and never here. Okay, so that's one benefit. Another benefit is when using magnets within a system, they're very dangerous things to be working with. You get contamination from materials. Now, because this material, there's no magnets in the track, there is some residual magnetism left when after the force has moved a lot over it. But most of the time, when it's not interacting with the forcer, the residual magnetism is very, very low, and therefore you get very little interaction with other materials, other metal materials.
Cool, excellent. So in terms of the applications that one might use this in, what kind of things do you see this being a particularly good product for?
Well, we've used it as simulators. So
a
lot of simulators would use this type of thing. Printing machines would be another area. Anywhere where you need high speed motion. Low payload. We're talking the payloads on these are fairly low, within a couple of kilograms maybe. But fairly, unless you want to parallel them up in massive numbers, then the payloads are relatively low. But high speeds, low payload, high precision applications. That's where you'd use them.
Cool. So in terms of control, I can see there's a cable coming out of it. What is it? Just standard interfaces, or is there something special?
No. This is basically standard. This is basically a standard servo motor. But it's been laid flat, if you like. That's all it is. Nothing special.
Fair enough.
Okay. And you would have to have some form of feedback device, a linear encoder of some description, mounted alongside it, and then you would use a standard servo drive, something like this, just to run it. Fair enough. That would be it.
So if someone was looking to design a product with this in, do you offer some kind of kit for them to evaluate the technology, or is it something that you can expect to just plug and play?
No. These we do 2 different styles. You can buy this whole thing as a complete stage. They go up to about 3 meters in length. So that would include the bearing set, the base frame, the encoder, the actual components of the force and the track themselves, built into a complete solution with a drive. We offer that, but they only go up to 3 meters in length. So if you need a longer system, or you have some system where you want to reduce the size and make it as compact as possible and engineer it yourself, then we provide the kit of parts and then help you with the interaction and the interfacing of it.
Cool, excellent. Well, seems like a pretty disruptive motor control solution. we're at EDS, obviously. So how have you found it this year?
Very interesting. I've been 3 or 4 times, and I've always found this show very interesting. There's lots of innovative stuff here, so I like to come along and have a look around, and also, be at the stand and kill 2 birds with 1 stone.
Yeah, excellent. Well, it's been really good to chat to you, Tony.
Thank you very
and
much.
Thank you for your time and showing us this motor innovation.
You're very welcome.
Thank you. So that was Motion Control Products at EDS with their MMF3 magnet-free track linear motors. I had a look at a load of linear motors after this product, and yeah, having a magnet-free track is not that common, and really, if you've ever worked with rare earth magnets, so much safer to have them not everywhere. Yeah, it's good that there's a few different ways that you can evaluate the technology depending on the size of kit that you need. So yeah, read the full write-up on the board page. And if you're working in a field that needs linear motion control, look no further. This is such a safe and low-cost solution. It's kind of amazing. It hasn't been done before. So yeah, check it out. Motion Control Products.
Hey, where my engineers at?